Okay, in the previous video, what we learned in the system of circles, we learned about the family of circle equation. For the two circles intersecting, S1 is equal to 0 and S2 is equal to 0. The circle passing through the intersecting points of P2 is given by S1 plus lambda S2 is equal to 0. If a circle intersected by a line L is equal to 0, the circle is S is equal to 0, then the equation of circle passing through the intersect points of circle and a line is S plus lambda L is equal to 0. That you learned in the previous video. Now welcome to this lecture. In this lecture I am going to discuss about the another important concept is radical axis. Radical axis. What is meant by radical axis when it exists? The radical axis is defined if the two circles are exist, they may be intersect each other, or they are in the distance, or they are touching each other externally or internally. Okay. Here I have two circles. One is S1 is equal to 0. The another one is S2 is equal to 0. It is the center C1 and here I have the center C2. Okay. Now, what is meant by radical axis? It is the locus of the points. The points are equidistant from the tangent to the lines. Okay, suppose here I have P and here I have Q. Say this is A. When AP is equal to AQ, from any point, if I draw a tangent to both the circles, the length of the tangent should be equal. Okay, let us say this one is B, right? Or C, D, E, F, N. Number of points are there which are equidistant from the point of contact of two circles. This locus is called the radical axis. The radical axis means, the definition we have to take down, the locus of a point which is equidistant from the point of contacts and tangents. The locus of a point which is equidistant from the point of contacts, where the tangents are drawn and passing through this point. Okay, is called the locus of the point. Here what you mean? AP is equal to AQ, like that. B, say some here, or and here S. BR is equal to BS, like that. Okay. So this line is called the radical axis of two circles. Right? How can you define this equation? The equation of radical axis of two given circles is S1 minus S2 is equal to 0. You observe that if you S1 minus S2, the x square terms and y square terms get cancelled. Only xy terms and the constant remains. So it represents a line. A line equation is linear. Right? That's why we are taking S1 minus S2 is equal to 0. And one more thing you have to remember that if S1 or S2 having the coefficients other than 1, then you make it in the standard form. Right? Make the coefficients of x square and y square to 1. Then only you can subtract S1 minus S2 is equal to 0 or S2 minus S1 is equal to 0. That gives you the radical axis. Suppose if the two circles are touch each other, then what happens? The two circles are touch each other. S1 is equal to 0 and S2 is equal to 0, where S1 is x square plus y square plus 2g1x plus 2f1y plus c is equal to 0, plus c1 is equal to 0. And this one is x square plus y square plus 2g2x plus 2f2y plus c2 is equal to 0. Then this line which passes through the common point, the contact point of these two circles is called the radical axis. And also you know that this radical axis is common tangent to both the circles. Common tangent is said to be common tangent. Here also the equation is, this equation is what? Also known as radical axis. What is the radical axis formula? That is S1 minus S2 is equal to 0. So the equation of common tangent when the two circles are touch each other, this is transversal, no? Is called the common tangent. Therefore, the common tangent equation for both the circles are touch each other is S1 minus S2 is equal to 0. In the case 3, suppose my circles all intersect each other, then what happens? If my circles are intersect each other, then the radical axis is like this. It passing through the intersect points of the circle. Say some PQ. So PQ line is called the common chord here. You know that this line is chord for this circle and this circle. S1 circle and S2 circle for both the circles. That's why the equation of common chord also S1 minus S2 is equal to 0. That means the radical axis becomes the common chord when the two circles are intersect each other. If the two circles are contact each other, touch each other externally or internally, then the radical axis is called the common tangent. If the two circles are intersect each other at two different points, then the line of radical axis is also known as the common chord. Right? S1 minus S2 is equal to 0. Right? Okay. Write down this. And after this, suppose there is three circles. This one is one circle and this is the other circle and this one is the other circle. Okay. These are the three different circles. Let us say S1 is equal to 0, S2 is equal to 0 and S3 is equal to 0. Right. Then how can I draw the radical axis for this? You know that for these two circles, I can draw like this. This is my radical axis. This equation is S1 minus S2 is equal to 0. Right? And then suppose I take S2 and S3 circles. This one is S2 minus S3 is equal to 0. This is also a radical axis. And if I want to take the S1 and S3, this is S1 minus S3 is equal to 0. This is another radical axis. How many radical axes are there? 3 radical axes are there. Okay. What you observe, these 3 are concurrent. These 3 are concurrent. They meet at one point. This point, suppose say as P, is called the radical center. Radical center of a circle. And one more thing, you know that when it is possible, if the centers of the circles C1, C2, C3 are non-collinear. Non-collinear. Okay. If these are collinear, then what happens? They are not intersecting. Suppose my circles are like this. Okay. The radical axis of this one and this one is like this. They are not intersecting. Then we can't get the radical center. So the radical center means the intersect point of the concurrent point of the radical axis drawn for the circles S1 is equal to 0, S2 is equal to 0 and S3 is equal to 0 is known as radical center. Radical center of given circles. Right? Let us do some problems on this. And also, we have some properties of this, that we are discussing. Please wait. Right, this one is the radical center. The radical center is the intersect point of the 3 radical axes. properties. Number 1. The radical axis of two circles is perpendicular to the join of its centers. That means these are the two circles. Here we have the 90 degrees angle. Right? This is one property. And the next property is, the second one is, the radical axis is bisect the common tangents of two circles. Right. What is the meaning of this is, if here I have one circle and this one is another circle, right? And this one is this is called radical axis. This is the, you know that this is common tangent to both the circles. This type also, what is this? This is the direct common tangent, no? This direct common tangent or transversal common tangent or any tangents, the radical axis divides equally, it bisects. Okay, that is this statement, right? And then the third one we already discussed. If the two circles touch each other, then the radical axis is known as its common tangent. And the fourth one, if the two circles intersect each other, then the radical axis is known as common chord. See this question. On the radical axis and radical center, find the radical center of the circles. Three circles are given. Right, x square plus y square minus 4x minus 6y plus 5 is equal to 0. Say this one is s1 is equal to 0. And x square plus y square minus 2x minus 4y minus 1 is equal to 0. This you can say s2 is equal to 0. And x square plus y square minus 6x minus 2y is equal to 0. This one s3 is equal to 0. First of all, what do you find? First find the radical axis, then the intersect point if you find, that gives you the radical center. Okay, solution. The radical axis, equation of radical axis of s1 is equal to 0 and s2 is equal to 0 is s1 minus s2 is equal to 0. Right? So I am subtracting this. X square get cancelled, y square cancel, minus 4x, this plus 2x gives us minus 2x. And then minus 6y plus 4y is minus 2y. plus 5, this is plus 1 plus 6 is equal to 0, or you can write it as x plus y minus 3 is equal to 0. Say this is the equation number 1. Right. After finding the radical axis between S1 and S2, I am going to find the radical axis between S2 and S3. Radical axis of S2 is equal to 0 and S3 is equal to 0. You can find any. Alright. From this, it is S2 minus S3 is equal to 0. You can write like this also. So I am subtracting S2 minus S3. X square get cancelled, y square cancel. Minus 2x plus 6x is 4x. Right? Minus 4y plus 2y is minus 2y. And minus 1 is equal to 0. This is our second equation. These two are enough. Why? Because the intersect point of the two, the third line also passing through that. You already know the radical axis of the three circles are meet at one point. Right. So I am solving these 2 points. Then how can multiply first one with the 2, right? That is 2x plus 2y minus 6, right? 2x plus 2y minus 6 is equal to 0. This is the first equation into twice, and the 4x minus 2y minus 1 is equal to 0. This is the second equation, and I can add these 2 plus 2y minus 2y get cancelled. 2x 4x is 6x, right? And then this one is minus 7 is equal to 0. This gives us x is equal to 7 by 6. After getting x is equal to 7 by 6, you have to find the y is equal to y value. From this, substitute in equation 1. Substitute in equation 1. What happens? X plus x minus y is equal to 3 minus x. That is 3 minus 7 by 6. 6 3 is 18. 18 minus 7 is 11. 11 by 6. So what is the radical center? The radical center of these circles is how much? X comma y. 7 by 6 comma 11 by 6. This is the answer. After this, we are going to learn about the common chord. The equation of common chord you already discussed, and the length of common chord that we have to discuss in the next one. See the one property on the radical axis. If the given three circles, say S1 is equal to 0, S2 is equal to 0 and S3 is equal to 0, whose centers are non-collinear and no two of circles are intersecting, then the circle which intersects all the three circles orthogonally is having center as the radical center of given circles, as the radical center of the circles, and the radius is equal to the length of tangent to any circle from the radical center. Okay, length of tangent to any circle from radical center. This is one concept which is very important one. Right? Here what it says, the orthogonal circle which is orthogonal to these three circles. Okay, its center is the radical center of the three circles, and the radius is the length of the tangent to any circle from the radical center. See one example on this. Find the equation of the circle which cuts the following three circles orthogonally. Right. This is based on that. First of all, what you find? You find the radical center of the given three circles. Say this is the equation number 1, S1, and this is the 2, this is the 3. Let us say, right? The equations are S1 is x square plus y square plus 2x plus 17y plus 4 is equal to 0. And the second one is x square plus y square plus 7x plus 6y plus 7 is equal to 0. And the last third one is x square plus y square minus 1x plus 22y plus 3 is equal to 0. Say S1 is equal to 0, S2 is equal to 0, and S3 is equal to 0. Right. First, the radical axis of circles 1 and 2. That is S1 minus S2. You already known, that's why I am directly substituting. 2x minus 7x is minus 5x plus 17y minus 6y is 11y plus 11y, and plus 4 minus 11 is minus 7 is equal to 0. Say this is equation number 4. Let us say, and the radical axis for 2 and 3, S2 minus S3, right? Plus 7x, this is plus x becomes 8x, and plus 6y minus 22y is minus 16y, plus 11 minus 3 is plus 8 is equal to 0. Or you can write it as divide with 8, x minus 2y plus 1 is equal to 0. This is my equation number 5. By solving this 4 and 5, these two are enough. These 4 and 5, you get the x and y value. That gives you the radical center. Alright? Multiply this with 5. So, equation 4 plus 5 times of equation 5. So minus 5x, this plus 5x get cancelled. Plus 11y, this one is minus 10y. 11y minus 10y is y. And then this is minus 7, and this one is 5 times of this one, 5 plus 5 minus 7 plus 5 is minus 2 is equal to 0. This gives us y is equal to 2. You understand, I think. Right? You understand this? And after that, substituting In equation 5, x minus 2 into y is 2 plus 1 is equal to 0. This is x minus 4 plus 1, x minus 3 is equal to 0. It gives us x is equal to 3. Therefore, radical center is equal to how much? 3 comma 2. This is the center of the required circle, which is orthogonal to the given 3 circles. After that, I want to find the length of the tangent. Length of tangent from where? From this point, from the radical center 3 comma 2 to any one circle. I want to take the first circle to circle 1. You know that, just substitute that and under root taking. So under root of x square means 3 square. 3 square is 9 plus y square is 2 square means 4. 9 plus 4 plus 2x means 2 3 are 6 and plus 17y is 17 2 are 34 plus 4 is equal to square root of how much it is? 9 plus 4 13, 13 plus 6 19, 19 plus 4 19 plus 4 23 plus 34. It is 57, I think. 38, 6, 44, 48, 9, 57. Root 57 is the length of tangent from 3 comma 2 to the circle 1. Now, what it requires? Equation of the circle, which is orthogonal to given 3 circles. You know the center and the radius. This is equal to radius of the required circle. Then use the formula x, suppose h comma k is my center, x minus h whole square plus y minus k whole square is equal to r square formula you can use and then find the required circle equation. See, x minus 3 whole square h comma k, this one is y minus 2 whole square is equal to r square is root 57 square. This implies x square plus y square here, and from this minus 6x, from this minus 4y, and 9 plus 4 is plus 13. 13, that 57 came this side, minus 57. So 57 minus 13 is minus 44. Is equal to 0 is the required circle equation, which is orthogonal to every circle.